All right, welcome back. So, we have one of these things. Okay, okay. You have an Effie, all right. I don't know quite where it's from. Apparently, someone posted this in the Otis server, and it's not. It's a multiplication-free Effie. Okay, that's the first thing I want to say. This is a functional equation that does not. Um, it doesn't use a multiplication operation. So, in particular, like the reason I'm okay, here's an example of a solution to the Effie, all right? Suppose f is any additive function, meaning such that f of y plus f of y is equal to 0 for all y. Then f is a solution to the functional equation. Because it is. So in particular, if I have a decomposition of the real numbers as a sum of, let's say, a direct sum of q modules a and b. Let me see if I can know how to do this. Then a plus b maps to minus a is an example of a solution. Wait, that's the whole solution set? No, this is not the whole solution set because, like, I think, like, constants are also solutions. Yeah, anyways, I'm just giving, I'm throwing this out here to start because I'm just like, well, you know, this is gonna have not good solutions, so I'm interested. Okay, but yeah, I agree. So we're gonna let S denote in the general situation, let's let S denote the set of possible values of y plus fy. Then, F becomes, is invariant under translation by S. By which I mean, okay, and is S closed under addition? Like if I take the sum of two things in S, is it also in S? I don't know if that's true. Sub y equals y plus s. And oh, that's a good point. Yeah, then S is closed under addition because if because for any y1, y2 in reals, we have y1. So the thing we plug in is f of y1 plus fy2, what, y2 plus fy2? Equals y1 plus y2. Oh, okay, so we're actually closer than I thought. Sorry, there's a plus sign here. Okay, so as is closed under addition, is it, Is it closed under, like, multiplication by rational numbers? This is a Z vector subspace of R. Is that a thing you can, like, I guess that's a thing you can do. Okay, hang on. Okay, wait, okay. Incomplete also says this is a string. Wait, I'm confused. Like, if S is X plus S1 plus X plus, no. S1, S2. Also, wow, I totally wrote the wrong thing here. This makes no sense. This is Y1. It's closed under addition. I guess that part is fine. Well, okay, this is a long. Actually, if I just plug in Y, okay. Wait, actually, okay. So, is the following a complete description? Is the following a valid description? Proposed description. Let S be any Z submodule of R. Choose an arbitrary function. I need some notation for some arbitrary. There's always someone in the background taking. Wait. Really? How bad does it sound? Is there a way I can listen to my own audio? I don't actually know. Is it the... Well, I mean, the thing is, I also don't hear background noise, and I'm, like, actually here. So I'm trying to figure out if something's messed up with the microphone. They stopped. Okay, let me... Alright, let me try... Okay, we tried the advanced strategy of close the door. So... If it still comes up again, let me know. Where was I? Anyways, choose an arbitrary function from R mod S. See, what? No, like, who uses additive subgroup? Wow, as soon as I did that, I lost. Where did it go? Oh, Shiba. This thing. I didn't say Z submodule, okay? It's not a vector space. Z is not a field. Choose an arbitrary function R mod S to S. And let f of x equals x minus psi of x, I guess. Sorry, no. Psi of x minus x. Is this a... First of all, okay, this is well defined because S is actually a Z submodule. Okay, well, I'll write additive subgroup for the people who want to see additive subgroup. But I think of it as Z submodule. I think usually when I talk about group, I don't know. I feel like the typical example of a group in your head shouldn't be an abelian group. Maybe I'll put it that way. Like, abelian stuff is a lot better behaved than the non-abelian stuff. But anyway, Z modules and abelian groups are the same thing. But I feel like I prefer to think of it as... It doesn't matter. I claim that this is a solution. And then well... Yeah, the claim is that this is a solution and every solution is of this form. I think that might just be true. Yeah, so, okay, everything of this shape satisfies the original equation. And conversely, like if I define S, and conversely, if I define S, then S is closed under addition. And what I need to check is that if X and Y are finitely venerated. Oh my god, I can't believe there's an argument in chat about this. Anyway, well, what I want to show is that if X and Y differ by an element of S, then f of X minus f of Y does what I want it to do. Which is, okay, that's actually just true. Like, yeah, no. What? Hang on. I'm now more confused than I was before. Like if I... Hang on. No. Wait. Am I a stupid head? I think I'm a stupid head. Hang on. This is wrong. This is the wrong description. This is not what I want. I need to also, for each input, So okay, so this is an element of S. No, but I do actually want like a bare X here. So something's wrong here. Wait, I'm confused. Sorry, I don't. I think I lied, and this doesn't satisfy the FE. If I plug this in, this is an element of S. So the two things are like. Oh my god. No, wait. Does this work? Am I crazy? Like, okay. What is f of x plus y plus f of y, right? If I use this definition, so y plus f of I is an element of the set S. So, well, I mean, let me write like x plus y plus f of y minus x plus y plus f of y, right, is what I wrote here. And this, and this is equal to psi of x. This, and this is like not equal to psi of x minus x, right? Right, it's actually, am I stupid? The y plus f of y just gets annihilated. I know, I know, but my point is that I think this equation here is wrong. I think this is not the right equation. Am I? X plus y, f y. Wait, what? F of x plus y plus f of y equals x f of x plus psi y. What is psi? Wait, am I not plugging this in correctly? Like, if I literally take, like, plug in x plus y plus fy into here, this is what I get, right? Like, I agree, this part disappears, but yeah, this is wrong. Okay, cool. Great. Yeah, alright. Let's try that again. Like, I think the problem is that somehow the issue is like this is taking too many values, right? Like I cannot even get like the constant functions are not of this form, and constant functions definitely work. So I somehow messed something up. Yeah, but okay. If I fix a thing like this, can I write a definition of f that's valid? Also, here's a different question. Is 0 in S? Like right now I have S is closed under addition. That is actually not the same as the sum module, actually. I also need it to be closed under, like, I guess S is non-empty, but I don't have a promise right now that 0 is inside S. Okay, so this is garbage, and also I don't have 0 in S yet. Psi should be a choice function. What is choice function? Like, what is the domain and codomain of psi? phi of x minus... Oh, you wrote psi. Okay, I'm gonna try the choice thing. So, arbitrary function psi and what is a good name for a choice? Row. Okay, so row 2 is that'll take every real num. Okay, so for every... Wait, now I'm even more confused. Alright, I get it straight. So for every x, you pick something in... You take it mod s. And then in that equivalent... for that whole equivalence class, you pick a representative. Yeah, it feels like you can absorb the phi. Okay, so choose a function row which behaves well in equivalence classes, and also for every... Okay, so for every equivalence class mod s, you pick a number such that r of x is cumulative to x mod s for all x. So for every and then it's like row of minus x. Is that what's going on? So for every equivalence class, I pick a representative modulo capital S, and I claim that works. Okay, so now does this satisfy the freaking condition? Well, first of all, is it true that S is the set of numbers of the form? Okay, to check that these all work, what I do is note that y plus f of y, by definition, is in S. Do I want the minus? I don't think it actually matters if I put the minus sign inside or outside. We'll leave it inside. Hence f of x. Oh god. No, never mind. I take that back. We're gonna put minus on the outside. It's so annoying if it's on the inside. Hence x equals row x equals row y x plus y minus row y. So they work. Okay, and then conversely, I want to show every function is of this form. That's just true, right? Actually, now that I have written the right equation. Like, what I need is... Why am I... Well... Hang on. Why is 0 in S? Yeah, I agree they should be the same thing. Why is 0 inside S? That's not... Like, in order for mod to make sense... I mean... Oh, I see. I should redefine S. Well, actually, yeah. I can literally just let S be this thing. And then everything's okay. Like, I just let S be the set of things. Yeah, I agree. I should let S be the set of, like... This thing, take it as a Z module generated. So conversely, given F satisfying, if we let Z, then F is invariant under shifting by S. And this basically, the claim is that this should force F to have the, in other words, F of X only depends on X modulo S. And then I think everything is... Or, no, is that bad? No, I think this is okay. I think this is just fine. Yeah, so I think this is just it, and like, yeah, I think that's fine. For each, yeah, so for every coset, we pick a representative of it. I don't know how you typically denote cosets. I don't know. Yeah, I think that's all there is to say. I confused myself a little bit about what the shape of the solution should look like, but it should just be this. And then, just to connect, to spell it explicitly, like examples, if s is 0, then f of x, then you recover f of x equals minus x. And to recover constant functions, if s equals r, recover constant functions by choosing rho of x. Well, rho is just the identity function and not... oh, sorry, rho should be a constant function because there's only one representative. Well, okay, alright, yeah. It doesn't matter what rho is. Okay, I think that's it. That is actually a complete description, and also that took a lot longer than I would have cared to admit. I'm surprised that, like, I felt like I was expecting this to matter somehow, like this closure under addition, you know, but I guess it's baked in, so we're okay. And also, why did people vote for this problem? That's the actual question I have. Anyways, have we proved this yet? No, I think the thing on the right of the screen is a complete solution. Like, it's just like, it's basically saying, like, here's how you describe the set of solutions in a way that makes it obvious that you cannot simplify it further. And the proposed description just satisfies the FE and is obviously as good as you're gonna get. Okay, so we're gonna do the... Okay, so I'm just gonna type this up quickly. We're gonna... It could be monsters. It's a little weird because it's just like, well... I mean... Yeah, like, it's almost like the problem doesn't actually use addition either. Like, it kind of uses addition in the sense that you need the addition in order for take mod s to be well defined. I.e. for all This is a nothing burger of a problem. I don't know, it's... It's kind of a weird thing because in normal problems, you know, you can imagine like, a normal problem gives you a like a description of a certain thing, like find all integers n such that, I don't know, n squared divides 2 to the n plus 1 was an IMO problem once upon a time. And what it means to do that is to give like a clear description of the set that obviously can't be simplified further. For example, maybe if a problem is about find all n, if you get the answer, if you find that the set the problem specifies is the even integers, the answer is even integers. Or if it's like a finite set, like n equals 1 and or equals 3, you say the answer is the set 1, 3. But in this problem, it almost feels like the hardest part of the problem is realizing that the description in the problem is almost already in simplest form. And what this is doing is that it's basically, there is a little work happening, but it's mostly like, here's a way to translate the condition into such a way that now it's obvious you can't do any better, because it's literally any added a subgroup and then pick any representative from each coset, and then it's obvious that you cannot improve this description. But okay, yeah. Okay, we'll just leave it at that. Unless there's an AOPster to post this in, I'll just conclude this episode here. But yeah, I would have liked that to take less time, but yeah, it is what it is. For those of you on YouTube, thank you for tuning in, and we'll see you all next time. Yeah, answer all FEs by saying the set of functions is the set of functions for which this equation is true. That's definitely what you should start doing on every contest. I'm sure the graders will really appreciate it.